So now when we know what is transportation tableau, how to construct the transportation tableau, we'll start with the transportation algorithm. Transportation algorithm. How do we actually find the least transportation cost? See, the first step here is to find the basic feasible solution. You'll have to compare to what I am saying with what I said when I was um, giving a lecture on simplex method. So the first step is to find the basic feasible solution. The second is using optimality conditions. Using the optimality conditions of simplex method, you have to find the entering variable. You have to find the entering variable. If you have lost what these terms were, you can go to what these terms are. You can go back to video on simplex method and understand. But even without going into them, you'll understand. I'll deal everything here also. So what we do, we find the entering variable. If the condition, this condition is satisfied, if it is satisfied, just stop. Else, go to 3. If it is not satisfied, you go to step 3. Now you'll use feasibility condition. Use feasibility condition to find what of simplex method, to find the leaving variable. And now you have start with a basic solution and then go to step 2. Again optimality test, again entering variable. If it is satisfied, stop. Else, go to this. So you keep on doing this until you find the your optimality condition is satisfied. So this is transportation algorithm. We'll deal them step by step and you'll understand everything. Don't worry about it. First is to find the basic feasible solution. I told you we have 3 different methods to find the basic feasible solution. First is called the northwest corner method, second is called the least cost method, and third is called the Vogel approximation method. So let's start with northwest corner method. What I'll do, I'll take an example. I'll construct a transportation tableau so that everything is clear before you, all the transportation cost and everything, supply, demand, all. And using these 3 methods, so one by one, I'll explain to you how we solve transportation problems using these 3 methods. Okay, let me first of all draw the transportation model tableau. So this is our problem. This is the transportation tableau. Now, by now you must have got concept of how to read this table. So the production units are these 3 and these are the demand units. These are supply units, these are demand units. X11, X12, these are the volumes of the items supplied from this to this, from this to this, and so on. And these are the transportation cost per unit. Let's say these are in rupees. This is the demand side, that is your first consumption unit has demand of 5 only. Second has demand of 15, third, fourth, all have demand of 15 items. While supply is from first source, you produce 15 items, from second source you produce 25 items, and third source you produce 10 items. Okay. Now, let's get the basic feasible solution, the starting feasible solution using northwest corner method. Northwest corner means this corner, this is the northwest corner. Okay. So what actually this algorithm is, what actually this method is, it starts with this corner, and what you have to do is you allocate the maximum demand that is possible to this, then move to this point. Whatever is left, you have to allocate here. Then when this supply is over, then you turn down. Then whatever is the demand and whatever you are able to supply, you have to give to this. Let's say this is completed, then you drop to this. So this is the method. I'll just solve this so that you understand. I told you, you have to start at this point and whatever is the demand, allocate a maximum to it. The demand is 5. Let's allocate this. You have 15 items coming out of this particular unit, first unit. So what you have to do, since this is the demand, you allocate maximum, that is complete demand. You are able to supply 5 items from this. So you let the supply be this, that is X11 is 5. Okay. Now, I told you, go to this side. What is left? There are 10 items left of this particular unit. 10 is the demand, is here demand for this second unit. Is it less than the demand or equal to the demand? Yes, 10. So you are left with 10 items, and this second unit has demand of 10 items. So you just give this. So now your first row is complete. See, 5 plus 10, 15 items complete. Now what you have to do, you have to come down. That is, you went like this, then you come down to this. When you come down to this, what is this? The second unit can produce 25 units. What is demand left? See, total demand was 15. 10 we have given. Only left is 5. So you allocate it 5. Now you go to this side. When you go to this side, it produces 25 atoms. What is the demand? 15. You can allocate it from here. So you allocate 15. Okay. Still 15 plus 5, 20. 5 items are left still from this unit. So whatever is left, you give it to this because the demand is 15. So 5 units you have done from here. Still what you lack is 10 units, and the production unit is 10. The third produces 10 items. So like this. So this is most simple method, but it is not a very effective method. It is, the only beauty is that it is very simple. It does not gives you the minimum cost. It gives you just a starting solution. So as per this, the transportation cost, what it will be? If you calculate, it will be 5 items into 10. That is the cost per unit, plus 10 item into 2, plus 5 into 7, plus 15 into 9, plus 5 into 20, plus 10 into 18. So what you get is 50 plus 20 plus 35, 59, 135, 20 into 5, 100, 180. So what you get? See, 180 and 20, 200, 135 and 35. It is 170 and this is 100. So 270, 270 and 200, 470, and this 530. So what you get is rupees 530. See, sorry, not 530. It was 470 plus 50, so 520. So this is the cost of transportation from these 3 supply units to 4 consumption units using northwest corner method. I told you this does not give you a very good result, but it is the simplest method that you can use. Okay. Now let's see the least cost method. How we calculate the transportation cost using the least cost method. Second one. Now let's see the same problem using least cost method. In the first method, the cost was rupees 520. Now let's see in this method. I'm just rubbing all this because we'll be starting with a new solution. Okay. What we do in least cost method is that we try to find the least cost path. See how. We'll start with this first column. The demand is 5, which is the lowest cost per unit cell. See, this is 10, this is 12, this is 4. So this cell has the lowest cost per unit, and if our supply can produce this demand, we'll apply it to this. So we have 5, we'll allocate 5 from here. That is from the third source. Why? Because this was least. We are targeting the least cost. Okay, so this is done. Now let's move to this point. Which is the least? It is this one. See, 1472. The least cost is 2. And what is the demand? Demand is 15. For this particular unit, the demand is 15. Is this source able to supply 15 units? Yes. So what we do? We assign 15 to this. Complete. Now come to third one. Third one, the demand is 15. This and this, 1 and 3, these are closed because whatever the capacity was there, that has been used by the demand units. The only left is this one, the second source. So the demand here is 15. It can produce 24 items. Which is the least one? This one only. Even if this was least, we didn't have any option. We had no option but to choose this because this and this, there was no supply. So here what we do, this is least, so we allocate 15 items from second only. Okay, so 15 items from second. Now what is left is 10, and the supply unit is this only. So you don't have any option and you just put it. Okay, so this had 10 units. we have to allocate 10 units only. Now this is satisfied, this is satisfied 15, this is satisfied 15, this it has 15 units demand, but the supply is 10 only. Still we are left with 5, and from where can we get 5? Here no, it is full, this is full. This third one, it produces 10 items and we have allocated 5 only, so 5 is left from this third unit. Now the supply and demand is balanced. The number of items that we have supplied is equal to the number of items that is in demand. Now let's calculate the cost. It will be 5 cross 4 plus 15 cross 2 plus 15 cross 9 plus 20 cross 10 plus 5 cross 18. So this is 20 plus 30 plus 135 plus 200 plus 118 into 590. So what you get? See, 200, 165, 20. This is 385 and 90. So what you get is rupees 475. Now using that method, northwest corner method, the cost was rupees 520. So see, using least cost method, we have come to this price, this cost that is lesser. So again, I'm explaining this to you again. What we do, our approach is to get the least cost path. So what we do, we start with this, the first demand. The demand is 5, which is the cell that contains lowest per unit cost. Here it is 10, here it is 12, here it is 4. So this is the cost. Can this supply unit supply 5 units? Yes. So allocate 5. Clear? Now come to the second one. The lowest cost unit is this. Can this source supply 15 units? Yes. Just allocate it. Now come to the third one. It has the demand of 15. We have possibilities. See, we can supply from here, the third source. We are left with 5. So we can supply 5 from here also. But the lowest cost unit is this. So what we'll do, we'll allocate the maximum, that is 15 out of this, because this is least cost. Okay. Now 10 is left from this source. You don't have any option. You have to balance this transportation model, you have to give this. So 10 is allocated to this, whatever be the price. Now the only items left from supply unit is from third, 5 units. We'll put it here so that system is balanced. Your demand and supply is balanced, and then you calculate, you'll get the lesser one. Okay. So this was least cost method. Now what we'll do, we'll see the third one, that is Vogel approximation method. It is, refinement of least cost method, a bit superior than the least cost method. At least it gives, if not the best, but at least it will give value which is equal to this least cost method. So it is an improvement over least cost method. Third one, Vogel approximation method. What we do, see, we find out a penalty measure. How? What is penalty measure? Every row and every column, for every row and for every column, we'll find one penalty measure. What is it? Let's start with this column. What we'll do, we'll find the lowest cost per unit. It is, see, 10, 12, 4. So this is 4. And the next one, so after 4, this is 10. We'll subtract it. That's it. That is 10 minus 4. This is 6. This is the penalty measure here. Here you see it is 2 and the next one is 7, not 14. 2 and the next just greater than this is 7. So 7 minus 2, it is 5. Here 9 and 16. So 16 minus 9 is 7. Here you have 11, 20, 18. So 18 minus 11 is 7. Okay. So 6, 5, 7, 7. You understood how to find penalty measure. For rows, what will be the penalty measure? The usual way is to write it here. So I am writing it here. Here the lowest cost is 2. The next one is 10. So 10 minus 2, 8. This is penalty measure. Here the lowest is 7 and this is 9. So 9 minus 7, 2. Here it is 4 and 14. So this is 10. Okay. So the first step is find penalty measure for each row and each column. Okay. Which is the greatest penalty or maximum penalty measure? Which one is the maximum penalty measure out of all these? 1, 2, 3, 4, 5, 6, 7. See, 6, 5, 7, 7, 10, 2, 8. This is the maximum, 10. Okay. So what we do, the row or column which has the maximum penalty measure. Here we have a row which has the maximum penalty measure. So what we'll do, in that row which cell has the lowest per unit cost. You can see this cell has the lowest per unit cost. So we will select this cell and we'll allocate maximum which is in demand. The demand is 5 only for this unit. So we'll allocate 5 because our supply is able to supply 5 units. So using Vogel approximation method, we have given the first one, the value of the first one. Okay. Now, is the demand complete for this? Yes. Since the demand is complete, what we do? we cross out this particular column. Okay, so this column is crossed out. Now again what we'll do, we'll recompute the penalty measures. See, these will remain same 577 because we haven't changed anything. Here this will change. Now we have crossed out this column. So now the difference is, see, 2 and 11. So this will be 9, 29, 7. So again this is 2, 18, 16, 14. So 16 minus 14, 2. So this is the new penalty measure, which is maximum. This is maximum 9. So what we'll do, this row has maximum penalty measure. So we'll select the cell which has lowest cost unit. So this is the cell with lowest cost unit, and we'll allocate maximum demand. Is this unit able to supply 15 items to this demand, this second demand unit? Yes. So we'll allocate maximum 15 here. Okay. Okay. Now here you see that this column, that is the demand, is fulfilled. At the same time, this supply is also fulfilled. That is, you can either cross this row or you can cross this column. It is, the decision has to be taken arbitrarily. There is no science behind it. Either you cross this and then you work on this remaining table, or you cross this and work on this. We have crossed the first column, so I am just taking this arbitrary. I am crossing this second column now. Okay. So 5 we have allocated to this, 15 we have allocated to this. Now let's see this on this. This will remain same, 7, 7. What about this? This is 20 minus 11, so it is 9. This is 20 minus 9, so this is 11. This is 18 minus 16, so this is 2. Now which is the maximum? 7, 7, 2, 11, 9, so this is the maximum. Which is the lowest? It is 9, the cost per unit 9. What is the demand? 15. Is it able to supply? Yes. So what we'll do, we'll give 15 to this. Clear? This is our third allocation. Now this table, this column is complete. Now when you look at this column, do we have any option left? No, we don't have any option left. Logically, you just think this unit can supply 25 units only. We have given 15 units to this cell. We are left with 10 items. We don't have any option but to allocate this to this. And similarly, we don't have any option but it produces 10 items. We have given 5 items. 5 items are left. So we'll have to give it to this cell so that this is also balanced. So this is our, we have given the number of volumes to each x11, x12, all variables using Vogel approximation method. Coincidentally, this is just a coincidence that this is what we have got is same as what we got in the least cost method. Many times you will see that they'll coincide. So again, the cost will be 5 cross 4 plus 15 cross 2 plus 15 cross 9 plus 10 cross 20 plus 5 cross 18. It's the same, so the cost will be rupees 475. Okay, clear? So I'm just giving you a recap. What we do? We find out penalty measure. Penalty measure is for every row and every column, we take the least cost per unit and the next one. So this is 4, so next one is 10. 12 is greater than that. What we do? We subtract this from this. So 10 minus 4, this is 6. Here it is 7, 7, 7, or whatever you see, it is 7 and 2. So it was 5. So 6, 5, 7, 7. Similarly, we do for this. Row or column which has the maximum penalty measure, we select that row or that column and allocate maximum demand from the supply. If we have taken a row, we'll supply it from that row, that supply unit. And so we keep on going. When our demand is fulfilled, we just cross out that row or column and we move forward. Okay, clear?